Hi guys, myself Ankit. In this video we shall see another problem on LeetCode. Given an integer n, return array answer of length n plus 1 such that for each I, that I is lesser than or equal to 0, greater than or equal to 0 and lesser than or equal to n, answer of I is the number of ones in the binary representation of I. So the question what they have given is, with a, they have given an integer called, let's say 3, and you have to return an array answer of length I n plus 1. 3 plus 1. Why 3 plus 1? Because you need to find the number of binary ones in the binary representation of each integer from 0 to 3. So 0 to 3 means 0, 1, 2, 3. So 3 plus 1 is the array size. So we have to find how many number ones are present in the binary representation of all these integers and sum total of count we have to find of all the integers. So binary representation, you know how it is. 2 power 0, 2 power 1, okay, 2 power 0, then 2 power 1, 2 power 2. This is fine. So 2 power 0 means 1 it is, 2 power 1 is 2, and 2 power 2 is 4. So if we take an integer 3, how do we get the binary representation of integer 3? Uh, 2 plus 1 will be 3. So both 2 and 1 will be 1 and the 4 will be 0. So this is the binary representation of 3. Similarly for 2, if we take the middle one is 2, that is fine. So only for that 2 we give 1 and all other remaining digits we give 0. So this is the binary representation of 2. Then similarly for 1, how do we do? This 1 is fine, right? This is 1 and 0, 0. So this is 1. And if we take 4, 4 we have this directly 4, that will be 1, all others are 0. Similarly, last one we will do 5. 5 how do we do? 4 plus 1, 5 is possible. So 4 and 1 we give 1, 1 and the middle one will be 0. So total of 5. So these are the binary representation. This is how we do the binary representations, right? Now we have to check the number of ones in each binary representation. So in 0, of course, it is 0 only because all are 0. 0, 1, 2, 3. This is 4 and this is 5. For 0, 0 it is. For 1, we have one bit containing ones. Then two ones are there here. Here one ones and one ones, two ones in the 5. Our aim is like if they have given, let's say they have told given an integer called int num n equal to 5. Then from 0 to 5, that is 0, 1, 2, 3, 4, 5. In all these integers, we have to find how many ones are there in the binary representation. So all this we have to calculate. We have to add and give return count. So how do we solve this problem? So initially, so instead of taking all the zero count from 0 to 5, I'll take only one integer and the remaining integers, all other we can do like we'll run, give, of course, we'll give one for loop. And inside that I equal to 0 to n, let's say equal to n. So each number we will perform the same steps. That is not a problem. So I'll take now number 5. So n equal to 5. Only for 5 we will see, all other will come as if. So as I said here, binary representation is 101. How is it 101? This is 2 power 0, 2 power 1 and 2 power 2. So 4, 2, 1 it is. So 4 plus 1, 5 you get. Hence 4 only 4 and 1 you give 1 and the remaining integer whatever is present you give 0. So 101 is a binary representation of 5. Now in 101 how many ones are there? 2 are there. So initially let's say the count equal to 0. We have to get count equal to 2 by the end of the procedure. So how do we get this first bit, least significant bit, whether it's 1 or not? How do we check that? That is by doing AND operation with 1. So the binary representation of 1 is what? Nothing but only for 1 we need to have the 1 and remaining 0. So it is 0, 0 and 1, right? So when you do AND operation with 1 and 1 is 1, 0 and 0 is 0, 1 and 0 is 0. Hence you got the answer as 1. So basically it's what it is doing is it is looking at the least significant bit of the number which you are having and is comparing with 1, which also has 1 at the least significant bit. So if the number which you have taken has 1 in the least significant bit, it will of course result in 1 only, right? Because 1 has 1 in the least significant bit. So this will result in 1. Hence the count will get incremented, count equal to 1 now. So now for now this number is done. What about the remaining 1 and 0? We have to check for that also. So 1 is done. The remaining bits, how do we take that? That is by doing the AND operation. AND operation is nothing but, or not AND operation, right shift. Yeah, that is by doing right shift. Right shift with symbol is by 1. So right shift means nothing but if give right shift by 1, that is 5 by 2. So 5 by 2, how much will you give? Will you give 2.5, which is rounded off to 2. So now now 5 is reduced to 2 now. We have done the right shift. Let us see what is the binary representation of 2. 2 is not 4 to 1. So only for 2 we give 1, then others are 0. So for 2 it is 0, 1, 0, which is actually 1, 0, right? If we neglect the 0. So 1, 0 is nothing but this remaining digits here. Hence, to remove the least significant bit and get the remaining bits, we do the AND operation. And to check the least significant bit whether it's 1 or not, we do the AND, very sorry, yeah. To get the remaining bits except the least significant bit, we do the right shift operation. So right shift for getting the remaining bits. And to check whether the least significant bit LSB is 1 or not, for that we do the AND operation with 1. Why AND operation with 1? Because in 1 only we have the least significant bit as 1, all other bits are 0. So that we can get to know whether the least significant bit in the given number is 1 or not easily by doing the AND operation with 1. So if both are 1, then we get the 1. That's it. So now we got 2, right? Now again for 2 you do the AND operation with 1. Because for the remaining bits we have to do 1, 0. So 1, 0 we have, that is by 2. Right shift we did and we got. So you do AND operation with 1. Now at this time we are checking whether this least significant bit is 1 or not. So we are doing AND operation with 1. Of course this is not 1 because 0 here present. So 0 and 1 will be 0. 1 and 0 will be 0 and 1 and 0 will be 0 because for 1 except only the least significant bit has 1 and all other will be 0. So remaining bits will become 0 and only the least significant bit will become 1 if the given number has 1 in the least significant bit. So now we got the answer as 0. Do we increase the count by now? No, because this is 0, right? So now 1 is done, 0 is done, 0 is done, right? Only remaining 1 we have to take this one. So how do we get this? Again do the right shift operation of 2. 2 right shift of by 1. So this 2 by 2. What is 2 by 2? 1. So 1, what is the binary representation? 0, 0, 1. And you do AND with 0, 0, 1. So 0, 0, 1 and 0, 0, 1. Now you could see 0, 0, 1 means only 1 we have got. So at first 1, 0, 1 was there. For that we did the AND operation with 1 and we to take on the count of the least significant bit. Now then we removed this one and to get only the remaining 1, 0 we did the right shift operation by 1. Then we got 1, 0. So in that also we checked with AND operation with 1 and whether the least significant bit is 1 or not and we increase the count as per the result we have got. So after this is done, we need to get only the remaining one. For that, whatever previous number was a 2, we did right shift of that, means divide by 2, that we got 1. So this you got 1 now. Here you do AND with 1. This is of course 1 and 1, will be 1 and remaining will be 0. Hence the count will be increased to 2. So one count was for 5 and 1, and another count we got for 1 and 1. For 2 and 1 it was 0. Of course the middle element is 0. So after this is done, again you do the right shift operation. 1 right shift 2. That is 1 by 2. Of course it is 0. By this time you stop the 2. So until you get the whatever integer is that is 0, you have to perform this operation. First you do the and. By doing the and, you check the least significant bit is 1 or not. If it is 1, you increase the count. If it is not 1, you decrease the count. But the AND operation results in 1, increase the count. Otherwise, keep it as it is. And then once you do the AND operation, then you do the right shift by right shift to get the remaining bits. So yeah. First, let's declare the array. How to store in the array that I will tell. So int answer it should be because they are given in the question equal to new int of what is the length of this n plus 1. Because from 0 to n we are counting, that's all. So yeah, now we can start with for int I equal to 0, I less than equal to n and I plus plus. For each count whatever, this is only for 5. Similarly, we have to do for 0, 1, 2, 3, 4, 5. So how do we do? We run the for loop here. Then initialize count equal to 0 and let's say int num equal to I, whatever count number we have. So why this number is not equal to 0? Because at last until 0 you do the operation, right? The right shift should get 1, 0. So until that you have to perform the operation. So while num is not equal to 0, as I said, count equal to count plus num and with 1. So once you do the AND operation, now you have to right shift. So num right shift by 1. So this will divide the integer, that is that you know. Okay. So once this is done, after while loop, you get the count. You have to store it in array, right? So answer of I let it be equal to count. After the loop is done. At last you return the answer. That's it. So in this case, initially you start with 0. For 0 until for 0 will it run? No, it won't run because it's equal to 0. So count will be 0 only. Then you run for 1. So 1 and 1 will be 1. So that count will be incremented to 1. Then 1 right shift 1 will be what it is. 1 by 1 will be 1 only. So like that you do for all the numbers. Here 1 by 2 you do, not right shift. Right shift means 1 by 2. That will be 0. Hence it will be stopped. Similarly for 2 also, we start with 2. 2 and 1 will be 0. So count will be 0 only. And again you write it by 1. So 2 by 2 will be 1 and similarly for 1 and 0. 3 also 3, again 3 by 2. Then 3 by 2 will give you 1 and 1 by 2 that will be 0. So 4 it will be 4 by 2 that will be 2. 2 by 2 it will be 1 and 1 by 2 it will be 0. Similarly for 5 what we did. So we will run this. Okay, right. Okay, here one equal should be there, then only it will become statement here. Oh, yeah. Right. Successfully submitted. If you have any errors, please drop it in the comment section. We'll come after the video next session. And please subscribe to the channel and like the video. Keep learning. Thank you.